Hello and welcome to another episode of our podcast, Power On. Cable and transformer testing plays a vital role in maintaining the integrity of power systems. And today we have the privilege of discussing this topic with Markus John. As the managing director of HIGHVOLT Prüftechnik, he brings a wealth of knowledge in energy, power systems, high voltage test systems, with a history working in the electrical and electronic manufacturing industry. Welcome.
Thank you, Christian.
It's a pleasure to have you here. You have been part of the energy industry for many years. What keeps you fascinated by this field?
Well, I'm originally a very, very old man in this industry already. I have to say more than 30 years now, and I have experienced a lot of changes in the energy segment over the years. Mainly at the beginning, we were very much focusing on fossil energy and the normal generation of power. With nuclear was very much in the beginning. It was gas, it was oil, it was coal. And of course, that had a very shortfall over the time and not very interesting changes. But since a couple of years, of course, with the energy transition and with the changes which we see here, it's a very fascinating market and it is getting a revival in the electrical engineering. My background is electrical engineering, so I was always in the energy sector working, and now the latest years and this absolutely incredible change in the markets is very fascinating for me, having also the long history in this part.
And the engineers love always the changes and the challenges. Yeah.
Absolutely.
Yeah, it's great. Having witnessed various of these developments or changes in the sector, what key changes have you observed? Particular now, energy transition, you mentioned that, is gaining momentum.
Well, I think we are absolutely in the change from central energy or power generation into decentralized power generation with all the aspects. Before, of course, it was always the power comes from a power plant and then there was a distribution, and the old guys always knew, yes, there is this transformer necessary and this cable and this overhead line, and then we have the consumers. And these days now, where everybody is more or less also a producer of energy, if you have your PV panels on the roof or if you have your wind farms. So the transition is absolutely changing the direction of energy flow. And this is absolutely fascinating because it needs a lot of different aspects to be considered, which is giving us a lot of opportunities.
What has the energy transition specifically to do with the high demand for the cables currently?
As you can see, and we are very famous here in Germany with this corridor project, so Südlink or Südostlink are the ones where we have decided a couple of years ago we don't want to have further overhead lines. We want to bring the energy from North Germany to South Germany with cables. The political decision was taken because we don't want to have a lot of arguments against overhead lines, and therefore, of course, cables have got a very important role. On the other side, of course, this is land cable, but we have also a lot of sea cables who are starting to build a completely new grid in the world. So combining the Baltic countries or combining the Norway, Sweden with Europe, or UK is a very excellent example for that. A lot of energy is going now through sea cables because you have no other chance than to connect England with Norway, with Sweden and so on. So therefore, also the exchange in Europe from this renewable side needs a lot of and has a lot of higher demand on cables.
Why is cable testing, when we think about the onshore cables and the offshore cables, so important?
Yeah, well, if you have installed a cable once, you want to make sure as an operator that this cable will last for a long time. And I mean, we have just recently seen this example in the Baltic Sea that suddenly an electric cable or power cable has been destroyed. This comes now more to our attention because it is politically and considered. There were also a lot of cable faults in the history which were not so obvious in public. But if you have a cable failure in a cable from UK to Norway, you can imagine how many days you need to find the error or you find the fault location. And then to repair it also takes a lot of time. So if you consider whatever, some 100,000 euro or up to 1 million euro per day operational costs which you are missing, so then you can see how important it is that these cables are working properly.
Are there potential risks and specifically challenges? You mentioned the north-south link, for example, in Germany. Is there a specific challenge or is it always the same?
No, of course, this is absolutely a challenge. And this corridor projects, as we are building at the moment, is proceeding. It's also absolutely new technologies. The operators have never used 525 kilovolt DC cables yet. So there are smaller distances which they were operating it, also lower voltage levels. But with the corridor projects, now we are going into absolutely new technologies. And these technologies also are new for cable manufacturers. They are absolutely critical to develop cables which can hold 525,000 volts DC. Also, when they are producing these cables on land cables, you only can produce, for example, a distance of 1 kilometer, and then you need another kilometer. And the challenge here is also the combining or the connection between these cable segments, which has also, of course, a huge potential for errors. And if we have this every, let's say, kilometer, and if our corridor project is 700 kilometers long, you have 700 pieces.
So
which
joints,
at the end,
I think they call it joints.
Joints in the cable, and this is a highly sophisticated task also for people who have to do that work. And afterwards, you have first of all to make sure that this cable section of this 1 kilometer is working properly. But at the end, you have to make sure that the whole distance of 700 kilometers is working properly.
Gives a lot of opportunities, challenges, new technology comes.
Absolutely.
Plays, I think, a crucial role.
Absolutely.
Additionally, the transformer manufacturers need to expand also their portfolio to include the higher voltage levels. Therefore, their test space need to be either retrofitted or when they build a new hall, redesigned, rethinking. Why is this so important to integrate the considerations when they're planning for such a project in an early stage?
We are, as a HIGHVOLT in Dresden, we have a lot of experienced guys when it comes to test facilities and test fields. If you want to build a new test field, you have to consider a lot of different things. Not only the size of the test area is important. So if you want to test voltage levels very often, then you need 1.3 times the voltage of the cable itself. You have, of course, a lot of possibility that you have a flash over into the building. You have critical things to consider. If you want to measure also the losses in a cable, or if this cable is really fit for purpose, you have to consider a very good environment for this test field. And very often the producer of cables or also transformers, it's all over the same, are not the experts in designing a test hall or test field. So it comes very much about earthing concepts. So very important is the grid under the building. And we are experiencing at the moment very often that very big and global players showing up and telling us, we have already finished the civil design. Can you please double check quickly that it's all fine? And then we realize, well, the size is not correct. You should consider a little bit bigger dimensions, or the earthing concept has not yet been considered properly. So therefore, for them, it's very often a surprise, and they realize, oh, we could have considered HIGHVOLT already in a much earlier stage to avoid rework in civil construction and civil design.
So it's not just about the space that I have a hall. It's more about, okay, I have a test facility. I need building around it. So it's more important to think about the earthing concept and all other aspects you mentioned.
Absolutely. And this is not in the knowledge of the guys who are having a completely different task. They are producing cables and they are not building every year a new test hole. So we are very happy that we can provide this consultancy and these advisory services, and it's well received worldwide.
What aspects of the testing infrastructure need to be clarified at the very beginning of such a project? You mentioned the earthing project, earthing concept. Is there anything else which should be considered at a very early stage?
Yeah, of course, you have to consider what kind of regulations are valid for you for the tests of your transformer or of your cable. So what are the regulations you have to fulfill? Therefore, you have to consider what kind of test products you need. What kind of tests do you want to do? Is it a routine test? Is it a type test? What kind of tests are necessary? And as the rules are more or less known, but they are changing also over the years, or they have changed over the years. It's not known in many times by our customers. And this is an important aspect. And for HIGHVOLT, we are very proud that we are involved, we get involved very early in this stage. And then, of course, have also the opportunity to decide what kind of test components are necessary, how do we support the customers, and what equipment they should consider for these tests. So we have a very open situation at customers because we have this knowledge for what's needed for testing.
And also for mobile test system, we spoke about that cable before we talked about the test system in the building. And when I think about this cable connected with joints over a certain length, I can't bring it to that building, so I have to move my test equipment there. And I think we also have to consider that roads are limited.
Correct. Yeah, it's the next challenge. So the one is, of course, the fabrication in the fabrication facility. But then if you lay the cable and you are reaching, like the corridor projects, you're reaching 700 kilometers. The discussions are still ongoing with the TSOs whether they want to test only 40 kilometers or if they want to test 160 kilometers, for example. There are different philosophies still in discussions. What is the right way of testing? And we are, of course, a very strong supporter to test as long as possible the cable, because otherwise you have always, in these small distances, you also have, of course, always a part which will not be able to be tested.
Like a blind spot.
Yeah, these are blind spots. And the corridor project, if they are transferring 2 gigawatt of energy and one of these joints has a failure at 1 second to the other, you have to distribute 2 gigawatt via the other network. So this is a big challenge for the whole operators, which they have to consider.
Brings me to the point of standardization or SIGRE working committees. What topics are currently discussed in like IEEE, SIGRE I mentioned, CERT is for sure also a standardization committee which talks about testing in generally, transformer testing, cable testing.
Yeah, they are very important committees to really define the rules about testing, and they have a long history. And the industry, which is in this in the energy sector for so long, of course, has also sent always their expertise and experts to these committees to make sure that the design of these cables or of the transformers is according to the standard, which at the end makes it for us sufficient that we have really 24 hours a day power. It's not taken for granted. But then you have to decide how you want to test these components. Normally, if a transformer, for example, has successfully completed such a test, that was his most stressful situation in his whole life. If he goes for 30, 40 years in operation, these tests should be very demanding, but it should also not kill the component, but it should make sure that it will be fine for operation. In the cable sector, for example, it's at the moment quite interesting because with these long new cable segments and with the DC technology, there are a lot of new requirements coming up with these converter stations who are transferring AC to DC and the other way around. And the big cable manufacturers at the moment have the challenge that the cable has to survive in an environment where they have already 525 kilovolts, but for a very short time there can be a wave of another 500,000 volts. So in total this cable can see 1 million double the voltage for a very short time. But this short time, this cable has to stand with this power. And we cannot imagine, but you need a full big test hall, which is at the moment in many countries, the biggest building the whole country has. If you talk to Norway or if you see in Sweden, they are building the biggest halls only for doing such a test.
That's amazing, yeah. How is it handled? The working groups are making sure that the standards reflect the latest industry needs or challenges?
Yeah, well, the process is quite clear, and like the SIGRE or the IEEE have clear regulations. So they have certain specialized teams, and companies like MR or HIGHVOLT is sending experts to these teams. And then if they are looking into new standards, then they are trying to develop this kind of standard, and then they revise it and review it in all of their countries, and before a final decision is made, it takes a long time. But then everybody in the industry can be sure that it has been considered by really all the experts, and it makes sense that this regulation takes part in the testing.
Looking ahead into the future, what trends and innovations in cable and transformer testing do you see play a significant role in supporting the energy transition?
Testing is physics. It's like there is not too much innovation. It's always current and voltage and power, which you have to make sure that this is covered properly. Where the trend is going in future is about evaluation of the data. So also here we come, what can you do with the data you collect through these tests? Before, of course, everybody had this machine in front. He was taking handwritten notes, put that into an Excel file. Maybe that was already very high sophisticated. But today or in the future, it will be more like the cable can have its footprint from the birth as it comes in the factory until it is in operation for 40 years. We are discussing in the cable part, but also with the transformers, the aging of components, and this is very much related to the data which we can collect and which we can provide. Data which we collect in the early tests can be evaluated, sent into the cloud. Additional KI evaluation can be done, and therefore I think it will go also very much in the electrical segment, very much into the data-driven area as well.
So digital twin, for example, digitalization, monitoring, and cloud you mentioned, so it's a pool of data, yeah?
Since a couple of years we are developing a so-called cable monitoring system. And this goes directly into these areas. We want to help the operators monitoring this cable over the whole operation. And before it was like no monitoring available. The cable had a breakdown and you had to send somebody to find it out. If you monitor this cable online, you can immediately know if there is a short circuit or a failure. You can identify that, and very precise on a couple of meters in precise. And then the operator, if something like that happens, he can already send the service team to the right position. And the idea at the moment is also to see small changes in the cable. So if we have this 525,000 volt cable, small little electrons who are maybe destroying the isolation in this cable, giving a certain signal on the cable. Mm-hmm. And we are measuring this very small signal, and we can then also see trends and can give already indications to the operators from these joints, for example, at kilometer 260, if you have the next shutdown of your converters, then you can also change this joint and you avoid to have a failure with a lot of additional costs. So this data, and this is really, let's say, very sensitive because you want to listen to very little changes in this high voltage cable makes us possible to identify future errors.
Very, very interesting when I think about such a long cable to make a precise location of the area.
For example, yeah, absolutely. And this is something what the operators at the moment, where all the construction works is ongoing at the moment, don't have so much on the focus. It will come because at a certain time they will start the operation. Also other teams at the operators will take over. And then it's the question of how can I monitor this cable?
The question will for sure come. Interesting area. The last question, you have been so long in the industry, taking a look into the future. Nobody knows what's coming, but from your personal perspective, where do you see trends going on in the next 10, 15 years where you think personally this is very interesting, or which area should we all keep on the radar, especially in the energy sector?
It is absolutely at the moment gets really a push. I mean, as I said, maybe 10, 15 years ago, nobody was interested in electrical engineering because the transformer was working for forever, and nobody needed a new transformer. But with this renewable transition, and as I said, we are changing from consumer to producer, a lot of new opportunities will show up. In municipalities, we will definitely think about changing AC grid to DC, because you can transfer much more power on the same cable. We don't have to dig all the streets again and lay new cable. We maybe change the voltage level and we change the current from AC to DC, and we can use the same cable but transfer much more energy. Battery storage definitely will be a point which I think we are absolutely at the beginning. And therefore, all of these things, if we really are on the way to say we want to have a CO2 less or reduced energy production, then there is plenty of opportunities.
Plenty of opportunities to grow, plenty of opportunities to learn. You're still looking positive into the future and into an interesting future. It was a very, very interesting chat, Markus, and a pleasure to have you here. Thank you for all the insights and sharing your knowledge and your personal insights with us.
Thank you, Christian, for having me.
I hope you also enjoyed the series from cable testing, transformer testing, the various challenges. We spoke about one particular project in Germany, Südlink it's called. I hope you had fun. Thanks for watching.